Evening, my name is Marcel Ellenbogen. I'm from Israel Electric Company, and nowadays I'm responsible for asset management implementation in the network service group, in the network engineering division at the Office of Transmission and Storage. I'm a member of CEATI, and I also represent Israel Electric in the transmission line asset management and the SAP interest groups. One of my duties are also to introducing innovation in Israel Electric in a day-by-day activity. Being exposed to such a rich international activity give me the opportunity to fulfill my duties as asset manager enabler in Israel Electric, and by proving continuous improvement, such as the international standards demands. Of course, and any utilities, one of the asset management duties is to map the needs and to formulate the right question in order to expose the dilemmas of several managers which are dealing with the same problems but in different views. So by integrating all of the available resources, we have to find solutions that are effective, cheap, and sustainable, aligned with organizational targets and goals. So today we will speak about one of the problems that every asset manager or every manager in utilities are dealing with, the lack of wide area situational understanding in the moment of crisis. So we are speaking about not only preventing the high impact, low probability events, but also triggers for executing condition-based maintenance. So we all have serious difficulties in managing the preparedness for such event occurring and to respond to destructive events. So how can we characterize the dynamic behavior of an electrical grid across several regions, a transmission line going through several regions? How can we integrate all the data? How can we mitigate the risk of the occurrence of such a high impact event? How can we accelerate the recovery from such an event occur when we are speaking about large area power disruption outages? And how to intelligently use our own assets with minimum effort and investment. These are the dilemmas, and we in Israel Electric are now contemplating one of the possible solutions. We are trying to use our optical ground wire in order to transform them in a linear sensor for a multitude of detectable perturbations. The condition that we think that must be put forward are experience, identification, interpretation of any detected perturbation. This is a continuous learning process, and this can be done only by a good partnership, meaning the utility and the service provider must work on a day-by-day basis, and to explain to each other what are the problems that are facing. We are now trying to understand what's happening in our right of way. So Prisma Photonics tried to resolve those day-by-day problems by a project that started in 2018, and we would like to see that we can control and monitor our right of ways. We are talking about 500,000 of kilometers in the island-based network. So I will give now the microphone to Eran, my friend, and to continue from here. Thank you.
Marcello, thank you very much for the introduction. Let me share my screen and we can start with the presentation. Okay. So once again, thank you, Marcello, for giving the context for the mutual project that we have. And we will speak in this presentation about sensor technologies and its application for line conductor hardware insulator condition monitoring. A long name, but we'll get into the details and everything will be clear about it. My name is Eran Inbar. I'm the CEO of Prisma Photonics. And we will speak about our cooperation and a project with the Israeli Electric Corporation. It's a project that started in 2020 as indicated with an initial POC, proof of concept, that started even 2 years before, in 2018. The Israeli Electric Corporation is looking to cover aspects of safety, quality, and commercial needs. And our solution, PrismaPower, that monitor transmission line, covering all this in a single solution. In the project, what we did, we covered 2 transmission lines, 2 segments. The overall coverage in the project was more than 100 kilometers. Most of it is overhead lines, and part of it was even underground. And during this long and successful project, we shift from a pilot stage into commercial agreement, and more coverage and more use cases are planned in the future. I would give as a title this, I would say, very nice summary from Amir Livne, the Senior VP of Strategy of the Israel Electric Company, about the importance, the strategic importance of this pilot. The Israel Electric Corporation, I think that everybody knows, is managing most of the electric assets in Israel: generation, transmission, transformation, distribution, supply, and sale, and so on. And we are very proud in this successful partnership. A brief about Prisma. In Prisma, what we're doing, we're helping our customer to keep the most critical large-scale infrastructure up and running. And the grid monitoring or the transmission line is one of the most important segments. We will speak about the business model also that we have that allow the utility to test them and deploy in a very convenient and flexible way. The company was founded in 2017, and we are right now in advanced pilots and deployment phase. Let's speak about the solution, and maybe starting with just one example to explain the use case and the need. And this is the story of this specific tower. This tower is part of the Californian backbone of energy, Californian transmission line, part of the PG&E line. And I will take you back to November 2018. A failure in this specific tower started a side effect, a wildfire. Since today transmission lines are not fully monitored, either the failure or the side effect, the wildfire, were not monitored. And you probably remember this eventually evolved into the deadliest wildfire in California ever. 85 people died, tens of billions of damages, and so on. And this is exactly what PrismaPower, this solution, is all about: the ability to detect failure in real time and pinpoint the exact location, detect environmental crises like wildfire, lightning strike, icing, extreme wind, aspect of vandalism, and it's even more interesting to understand predictive and preventive aspect of the grid, therefore to see where problems starting to evolve or where we need to put the attention for predictive maintenance. You know, for all the use cases that I mentioned for transmission line monitoring, there are probably sensors that can be used for them. And you can think that installing those sensors on the towers can solve the problem. But when we start to speak about big scales, we speak about thousands of kilometers, then the cost of installing many thousands of sensors, the maintenance, the future upgrade, make this probably not economic or extremely expensive. And we're speaking about what we call sensor-free solution, how to solve this problem without installing any sensor on the grid or on the tower itself. And how it's done, because eventually we need sensor. The beauty is that we can use a pre-existing fiber, the OPGW, the pre-existing fiber as our sensor. So the whole installation will be placing the PrismaPower system in an existing communication room and plugging it into a pre-existing fiber. And that's the whole installation. Once you're doing it, a single system can cover 100 kilometers without the need to install anything on the tower themselves. And you can guess that there are two major benefits. One of them is the cost effectiveness, the cost per kilometer or the cost per impact. The other thing is the fast deployment. You know, it takes just a few hours to install a system. Therefore, in a few hours, you can monitor 100 kilometers. And this is a scalable solution. The meaning is, if I have thousands of kilometers, I'm placing a system every 100 kilometers, and eventually in the command and control, I'm getting a single and consolidated picture of the grid itself. So I can see a map of the grid, I can see the problem evolving on the grid itself, and I can analyze them. Let's speak about an example, and this is partial discharge or corona discharge. And this is part of the capability of the system. And this is something that we can sense and monitor. And the beauty is that we can do it 24/7 for 100% of the line simultaneously. So we can understand the trend over a long time. And basically what we are measuring is an acoustical signal, and based on our algorithm, we can translate it into a score, what we call the corona score, to understand per tower what is the corona score in real time of each one and one of the towers. And therefore, when the tower is passing the threshold, we can give an alert. But more than this, what we find out in the project, that this readout is fluctuating over time. So if you're coming with a camera or with a detector to a specific tower to try to measure it, maybe at this time, the time of measurement, it's not at its peak, and you will think that everything is okay. But when we're measuring 100% of the grid, 24/7, we can understand the trend and we can find each problem and problem. Let's speak about demonstrated use cases, what we did together, the Israeli Electric Corporation and Prisma Photonics during this mutual project. And let's start with what I just mentioned, the corona alert. So we did a measurement over the 400 kilovolt line, and we monitor a segment more than 70 kilometers. Therefore, we have more than 100 towers in this segment, even close to 200. And what we find out that not all towers are getting the same scoring. So we can pinpoint few specific towers that are more problematic than the other. Therefore, do a precise and very cost-effective predictive maintenance, because we know precisely where problems start to evolve, and we know which tower need and when it's needed preventive maintenance action items. So as you can see in the user interface, there is a map. You see the line. On the line, you get an actual icons when specific tower is passing the threshold, and you have a table so you know the tower number, the exact location, and the scoring. Let's just, we can zoom in and see how it's look like. In order to validate it, what we did together is we did a confirmation aspect, and we took a measurement device. We went out, checked, went to the towers that had high scoring, and in real time we can compare the sensors or the camera readout with the system readout and do a validation for towers that exceeding the threshold or towers that are beyond the threshold. We did also a validation of this measurement in another line, not in the Israeli Electric Corporation line, another transmission operator, just to validate the results. I'm not sure that you can hear the humming sound, because I don't know if the this online tool can transmit the light. But what we're right now playing is the sound of a tower that exceed the threshold level and therefore need predictive maintenance. Another use case that was tested and demonstrated is short circuit localization. So what we did is a short circuit detection. When there is a short circuit event, we can detect it with our system. And what's very interesting, we can pinpoint the exact tower. So it's not like we have it over tens of kilometers or a few kilometers. We can say exactly what is the tower. And as you can see in the picture, we can give an indication about the event, the time, and the very precise location of the event. And of course, in this case, we did cross-reference and we used the data of our partner, the Israeli Electric Corporation, and we saw that there is a match between the time of the event and the time of the interference recorder having the signal of the event itself. Another use cases that was tested was aspect of vandalism, and we gave alerts on security events like damages to the tower, hitting the tower, sewing, usually related to metal stealing, even tower climbing. So all those events can be found, located, and pinpoint. Therefore, we can say the specific number and specific location of the tower that this event is happening in real time. To maybe the last slide to complete is speaking about the forward direction and what we're doing to take this successful cooperation to the next step is extending the coverage in kilometer of this pilot, adding more segment, and speaking about an integration of our system with the Israeli Electric Corporation's SCADA system. Therefore, we can do cross-correlation between different detectors or different events, and this is something that can dramatically amplify the capability of the system. We're very happy to join the Israeli Electric Corporation in their innovation journey toward a reliable and a very high quality and safer grid. We would like to thank our partner, the Israeli Electric Corporation, for the opportunity and look forward to building a strong relationship. And thank you all for listening for it, and we will be glad to try to answer any questions that you have.